Hello everybody, how are you? Today we're going to watch the Carsat Crisis episode 5. Again, we are pleased to welcome Mr. Ian Kerr to the studio, who will start by refreshing our memory about the story so far.
Hello. Yes, let me try and remind you what we've seen in the 4 episodes so far. The main characters in our story are scientists and engineers who are busy trying to find the fault that has developed in a production unit. This production unit makes K40, a vaccine, and it's not here on Earth, but it's in a carrier satellite out in orbit in space. The main pump, which mixes the components, has dropped to half speed, and they have only 9 days, of which 3 days now have been used up, trying to discover what has gone wrong. They believe at first that it might be the chemical process, and the project director, Stan Mikowski, has investigated this to see if there was any impurity. He is satisfied that there's nothing wrong on the chemical side, so we saw in episode 4 his investigation into that, and also by a series of flashbacks we also saw the discovery of the vaccine, and we saw the testing of it in Africa in field trials. Since there seems to be nothing wrong with the chemical process, they now must investigate the engineering side, and the prime suspect in this is the main pump. And so in the episode that we are about to see, we see them checking the pump out. We again, by a flashback, see the design and the manufacture and the testing of the pump in process. So I think that tells us what we're about to get into today. Huh?
Thanks, Ian. Okay, so let's see the first half of episode 5.
Good morning, Mr. Burton. This is Stan Markowski, Project Director for the Carsat Vaccine Unit.
Dr. Markowski, yes, of course.
My colleague, Wilhelm Schroeder, spoke to you yesterday afternoon.
Yes, that's right. About the shutdown of your unit. He said the speed of our pump dropped suddenly. Well, we've been testing 2 similar pumps all night, but no sign of any problem. Frankly, I'm not surprised. The pump we supplied to you was rigorously tested, and my men are very reliable.
What's up, Dave?
Remember that pump for the space mission, the one we built? Matty says it's gone wrong.
That's not what he told me. He said it had slowed down. Could have been a power failure, or one of their controls went wrong.
Or maybe the pump went wrong. You haven't forgotten what happened.
I know we assemble our own electronic circuit boards which control the speed of the pump. The actual speed is monitored by a tachometer attached to the motor.
That could be critical for us.
With a variable speed pump, the operator can set the speed to any value. Now, these circuits will control it to an accuracy of 0.1%. The speed can be varied at any time, of course.
Don't forget, our pump will be in space and the operator will be on Earth.
No problem. Each pump is fitted with a socket for remote control as a standard feature. How remote you want to be, it's up to you. Morning, Jim.
Morning.
Now, these men are assembling a variable speed cassette pump. This is our model 202U, which we propose to adapt for your space unit.
And the motor is in the module, and this is the main shaft.
That's right. And these are the sun and planet gears which drive the rollers. Now, each pump is built either by one man or a team of two.
Don't you have an assembly line?
No, the same men build the pump from start to finish and also carry out the test procedure. Their names are on the documents along with the serial numbers. We can identify who's responsible for every product.
In case of complaint.
I'm glad to say we don't get many complaints. Now, each tube runs through a separate cassette, like this. And each cassette clips into the pump head, so. Now, you can have 16 channels on this particular model. Can you start it, Jim?
You see, as they turn, the rollers run against the tube as they rotate, and they force the liquid through the tube.
Now, the system is self-priming, which prevents any flow in the opposite direction, unless you reverse the motor, of course.
And this is what you call a peristaltic pump.
That's right. Now, it's ideal for controlling slow rates of flow. Another big advantage is that the liquid flows through the tube and never comes into contact with any part of the pump.
So there's no contamination?
There's no contamination of the pump by the liquid or vice versa. That's why these are widely used in medical equipment, such as kidney machines.
Can each cassette take tubes of different diameter?
Certainly, you can have several different flow rates, all operated by the same pump.
16 channels. That's enough to provide everything we need in the unit, plus redundancies.
Redundancies?
With 16 channels, we could duplicate every tube. Then if one splits, we could switch through a valve to a redundant channel, right?
Well, it all looks very promising. Mr. Burton, I suggest we discuss a system to deal with our different flow rates, plus redundancies.
Bob, perhaps you'd care to have lunch first, and I'll ask Matthew Brown to join us. He's our designer.
Good idea.
Thanks.
Didn't invite us, did he?
Trouble is, we're not buying a pump, only building one.
So, gentlemen, let's see where we've got to. Matthew.
Right. You require a 16-channel cassette pump with variable speed, which will operate in a voltage of plus and minus 2. Is that correct?
Plus and minus 2. Agreed.
Channel 1 will carry your base products at approximately 200 millilitres per hour. Channels 2 to 6 will carry the buffer solution with a total flow of 3 litres per hour. And channels 7 and 8 will carry the electrode buffer.
Well, that's fine for the moment, at least. We may have to make further modifications later.
All tubes will be duplicated to provide redundant channels, making 16 in all.
Right.
And don't forget the new tachometer.
Are you sure you want to replace our standard tachometer with a magnetic system?
Look, we will provide the wheel and a special detector, which is a semiconductor. It will be designed to match your existing fittings. You see, we have to be very certain about monitoring the speed of the pump.
I'm sure we can fit that.
Well, I think that covers everything. What now?
Well, Matthew will produce a design, which we'll submit to you, along with our estimate.
Naturally. Thank you, Mr. Burton.
Thank you.
We'll look forward to seeing your design.
See you in the morning, then, Dave.
Aren't you coming over the road for drinks?
No, not tonight. Picking up Tracy from the garage.
First day at work. Right, I'll see you in the morning then.
Yeah, take care.
Ta-da.
Hi, Tony.
Hi there.
Hello, worker.
Oh, hi there.
How's it going then?
All right so far. Spent most of today doing invoices.
How do you know what everything costs?
Well, that bit's easy. I use the computer. Does all the sums, too.
Good job they don't have to rely on your maths.
Night, Mr. Lewis.
Cheerio.
Mind you, I don't know what many of the parts are for, really. Some of the lads are very very helpful.
Yeah, I bet they are. You sure?
Careful!
That's dangerous, leaving that oil on the floor like that.
They're supposed to clean up before they go. I'll have a word with the boss about it in the morning.
Yeah, well, come on, we better be going. Your mother'll be wondering where we've got to.
The story. Yes. I think this oily floor is going to be something to do with latter part of the story.
Yes, I think
Yes,
there's
let's
some significance to it, obviously.
Yes, and also father visited his daughter's working place,
Yes.
garage or something. Well, a bit confusing, isn't it?
Yes, there doesn't
Yes.
seem to be much to do with the pump at the moment and,
No,
and the story,
no,
in fact.
no. Anyway.
But I think we'll see that she provides a diversion so that we worry about the reliability of the testing procedure.
Okay, so this part is full of information about the pump.
Yes, indeed.
So we have to talk about that a bit. I didn't understand why they need 16 channels.
Well, they have several substances that they want to mix in the chemical process. And so they outline what they need, and it comes to, in fact, 8 tubes delivering the liquid. They talk about redundancies,
Yes.
in fact, and what this means simply is that they want spares. They want to have 2 of every tube, so that should there be a blockage or should there be a split in one of the tubes, they can switch to another tube and...
Just in case, yeah.
Yes, so it's a safeguard, really.
I see. Well, I thought that they were talking about 1 tube is for mixing chamber and that kind of thing. So could you
For
elaborate?
mixing?
Mixing chamber, or just solution comes through the mixing chamber, and they need 1 pump for that. And
Yes, but there are probably other pumps. They do talk about the main pump, but there are other
not so
pumps.
very much clear about the other 7 pumps anyway for me. But okay, so are we given any information as to why they want to use their own tachometer instead of their, invention?
No, they don't. They don't want to use a standard one. All they seem to imply is that it's very important for them to be absolutely certain about the speed at which the pump is working, and they feel they have a superior means of monitoring that speed. So they're going to use their own tachometer. Again, this brings in an element of doubt into the story, so that we may feel that perhaps the pump was all right, perhaps the tachometer. Now, the tachometer is the instrument that measures the speed of the pump, we should mention, perhaps. Perhaps that, in fact, was faulty and not the pump itself. We don't know yet. We'll see.
Well, they mentioned about magnetic tachometer or something like that.
Yes, well, that's their own.
Yes. And again, well, they mentioned peristaltic, what? Pump.
Pump, yes.
Yes. Is it equivalent to variable speed
No.
cassette pump? Nothing to do with
it
that.
hasn't to do with that. The rollers that we saw on the main shaft of the pump move round, and as they move round, we saw that they squeeze the tube. So the tube is constantly being squeezed and relaxed.
You mean a cassette? The tube
The
in
tube
the cassette?
inside the cassette, yes. And we must remember there are 16 of those. So they're all being squeezed and relaxed. And as they relax, the liquid moves through the tube. This is called peristalsis, and in fact it's the process by which we move food through our intestines. Yes. So hence the name peristaltic pump. It squeezes the liquid through. And as they mentioned, the big advantage of it is that it doesn't flow through the pump itself, and that means no contamination.
I see. Great. Okay. So I think we are still in the flashback, so we have to be a bit careful about that. Let's see the other half of the episode 5.
Yes. Yes, we've got that in hand. No trouble at all. Okay. Yeah, I'll be in touch. Bye. Now, Jim, you remember those customers from Frankfurt came here a couple of months ago?
Oh, yeah.
Well, they've ordered a custom-built 202U for their space mission. I want to use it as their main pump. I want you to handle it. It's obviously for remote control operation, so it'll be in the M2 mode. The electrics have been changed, and there's a new tachometer, but I think the fittings should still be the same. Now, the tachometer output will still be 1.5 volts DC at 100%. If there are any queries, come straight to me. All right?
Right.
And they're in a hurry.
Aren't they all? Dave. Dave.
What's this?
It's a one-off unit, specially adapted for space.
Space? I'll be going into orbit.
Yeah, that's right. But you keep your feet on the ground till we finish the job, okay? Come on.
How's it going?
Oh, had a bit of trouble with the tachometer.
That's their own design.
Yeah. Well, the fitting was 0.03 mil out. But we've managed to ease it. I think it'll be all right. Touch wood.
There were no touching wood on this job. I want nothing left to chance.
Yeah, well, we'll be testing it this afternoon.
Good.
Okay, she's ready.
Right, let's start from the top of the list then. Serial number.
96533.
All right. Indicators illuminate. Okay. Control knob and potentiometer.
Paging Jim Blake. Telephone call. Outside call for Jim Blake.
Jim Blake? Tracy? Oh, what's happened to her? Look, if it's that oily floor of yours... Yeah, OK, I'll get down there right away. But I want to know exactly what happened. Dave, it's Tracy. There's been an accident.
What's happened?
Well, I don't know, but I'm going to the hospital.
What, right now?
Well, right now, of course. I'll be back as soon as I can. I want to see their accident report. They just shouldn't leave airlines lying around where people are walking.
Oh, it was my own fault, really, Dad. I wasn't looking where I was going. I was sort of walking backwards at the time. It would have been all right otherwise.
Yes, well, you've just got to be more careful in the future. You can't mess about in workshops.
No, Dad, I'm sorry. What about your work? Well, never mind about you being away.
Oh, that'll be all right. Morning, Dave.
Hi. How's Tracy?
Oh, she's okay. We had to wait ages for the x-rays. It's too late to come back here.
She's okay, though?
Yeah, she's fine. A bit shaken up. Where's the pump we're supposed to be testing?
I've done it.
You what?
I did the test.
You're not authorised to do that by yourself. We'll just have to do it again, won't we?
We can't, Jim. That pump went out to Frankfurt first thing this morning.
Message for Mr. Warren. Mr. Warren to the phone, please.
Come on, lad. Let's go and see Burton.
So, Dave did the test on that pump on his own?
Well, yes.
You were the senior man on the job and you left a junior to test the pump?
Well, it was my daughter, Tracy. She had an accident at work. I had to go down to the hospital.
You left a junior to run the tests? So why on earth didn't you come to me? I could have made arrangements. I could have seen to it that Mr. Ferguson took your place.
Mr. Burton, Jim didn't know about it until it was too late. It was my fault.
Never mind whose fault it was. In future, if there's any problem, I expect to hear about it at the time.
Right.
Well, fortunately for both of you, I happen to know there was nothing wrong with the test. Just to be absolutely certain, I asked Mr. Ferguson to do a second quality control check just before the unit was dispatched. Both sets of results agree in every detail. That pump was in perfect condition when it left this factory.
Any news on the pump yet?
Yeah. I've just spoken to the production manager at the factory. They've been carrying out tests all night. They say they're sure it can't be the pump causing the problem. I'm inclined to agree with them.
Yes, me too. Their reputation is excellent.
Where do we go from here? Well, Ian, did you catch the last word that Mary said?
It was very difficult, wasn't it? I think she was saying, where do we go from here?
Where do we go from here?
She was talking to herself, I think, because Mary is not an engineer, of course, and she's the discoverer of the vaccine. And for her, she knows the chemical process has been checked out and is fine. They now have checked the pump, and it seems to be okay. So she wonders what else, I suppose, they can check. But we'll see in later. There are plenty of things still that the engineers can test.
Yeah, we are looking forward to that. Anyway, they are mentioning about touch wood. Do you remember?
Yes, not really a scientific term.
No.
In fact, it's a superstition.
Superstition?
Yes. It's something we say when we are chancing fate, tempting fate a little bit. For example, if I say, I haven't had a cold all year, then I'm really inviting fate to strike me down and give me a cold. So to cover ourselves, we usually actually touch wood, we say,
why
touch wood.
It's interesting, isn't it?
And of course you saw the manager there pick that up, and it was meant to be a little bit of humour, I think, by Dave, but the manager was not taking it humorously. He said, there'll be no touching wood on this job. I want nothing left to chance.
I often heard British people use this word. No touch wood.
Yes, I do it.
Yes. Okay, getting back to the story. You know, Tracy, daughter of Jim, and at first she doesn't seem to be any connection with the story at all. But I think she has a very important role in this pump things.
Well, I think I mentioned earlier, she's really just a diversion. We need something to take Jim's attention away from the testing of the pump, so that there is the possibility in our minds that the pump may not be 100% efficient. But we saw that, in fact, the pump was tested again. The manager arranged for somebody else to do a double check. Hence the title of this particular episode is Double Check. So the pump was double checked, and they're pretty certain that there was nothing wrong with that pump. We're still left, I think, with a little doubt in our mind that perhaps the tachometer that measures the speed may not be functioning properly. That may be a source of the problem, and I have no doubt that will be tested.
And that manager, Mr. Burton, is very efficient manager. I mean, a very able person.
Well, he seems to be. He shouts at his employers anyway.
So I think there are a few difficult words. Well, actually, there are many. But for instance, DC. Do you often use this word, DC?
Well, DC is the stands for direct current. It just simply means that the electricity all flows in one direction, and that's quite usual in a small pump like this.
And also custom-built 202U.
Yeah, the 202U is simply the model number. Custom-built means that it has been specially designed for use by a particular customer. So no two pumps are completely the same. And we saw that they ordered specifications to meet their needs on this particular pump. And it was then built by hand, not on an assembly line.
And potentiometer?
Potentiometer, yes. Well, with the testing that, when they actually ran the test, it's just simply a means of measuring the current or the voltage running through the pump.
Well, this was very difficult, and maybe I won't use this word at all.
No, and not at all important to the story, really. It's just part of the technical jargon associated with the testing of the pump, really.
Well, then 30 seconds left. So again, I move into that Tracy things. And Tracy was injured. Why? Why was she injured? That's something to do with that oily floor.
No, in this case, I think she tripped over an air hose. She stepped backwards. She wasn't
in a garage where she's working.
So they have a hose pipe there for pushing air into the tires, and she must have stepped backwards over it.
Oh, I see. Okay, thank you very much, Ian. So, see you next week. Goodbye, everybody.
Yes. Goodbye.
Hello everybody. Welcome to English Conversation 2. My name is Satoshi Sugita. I'm your host today. Our reporter today is Ms. Vera Calloway from Los Angeles.
How do you do, Mr. Sugita?
How do you do? This is the first of a series of 3 programs